everyone, it's Ken here. As you know, it's going to take quite a few springs and things to animate this T-800 arm. And in this video, I'm going to show you how I made the springs, and I'm also going to show you how I separated a swivel joint from a larger part so that I could use it in the arm. So let's head down to the workshop and get started. The process of building the prototype required that I find multiple places within the model that I could insert springs so that the parts would snap back into their original position when I animated it. And there are springs everywhere. There are springs inside these cylinders. There are springs inside all of the finger joints. And the problem with coming up with something like this is that the springs have to have exactly the right tension in order to work, plus they have to fit within the allocated space, whether they're inside these cylinders or inside finger joints. Now, because there's no way to possibly know what the specifications of each spring you're going to need would be, you can't just run out to Springs R Us and buy a bunch of springs. This process requires a tremendous amount of experimentation. So what I did was I went out and bought a range of piano wire from 14 thousandths of an inch up to 29 thousandths, whereby I had to make a whole bunch of different springs to try them and finally figure out which ones would work best in this model. So the next question is, how do you make a spring? Well, if you think about it, a screw is nothing more than a spiral wrapped around a cylinder, which is exactly what a spring is. And since my lathe is more than capable of cutting threads, as you've seen, it occurred to me that it's probably capable of making springs as well. So I looked through the G-code, and I found one which synchronizes the spindle to the motion of the cross slide. And you can specify for each rotation of the spindle how far to advance the cross slide. So for example, if this screw were 12 threads per inch, I would want the cross slide to move 1 inch every time the spindle rotated 12 times, and that would give me 12 turns per inch. So to make this all work, I began by making some mandrels of various diameters based on how small I wanted the spring. And then I made this part to fit in my cross slide. It's just a cylinder with a hole in it. I cut a V-groove in the front to guide the wire, and that'll pass through and wrap around the mandrel as the cross slide advances. So let's head over to the lathe and see how this actually works. I use ER16 collets to hold the mandrels because I have them in the small sizes necessary to do that. The mandrel needs to be supported on the other end, so I've made these small bushings which I lock into my cross slide. Now the cross slide will not be moving in the X direction, so it will stay aligned with the collet, which will keep the mandrel nice and straight. So I tighten up the collet. Now here's the wire I'm using. It's only 14 thousandths of an inch in diameter, which is, quite thin. The wire comes on these spools, and it's absolutely imperative that you unwind a length of wire long enough to do the spring you happen to be making, and then cut that off because you certainly don't want that spool to get wrapped around the mandrel. That could be very dangerous. Now I'm threading the wire through that holder that I made in the cross slide. I bend an L shape on the end of the wire, And then I just use a small piece of electrical tape to MacGyver the end of the wire onto the mandrel. Something has to hold it when this thing starts turning. And after a few wraps of the tape, I bend the wire back up on top of itself and wrap it a few more times, and that's just so the wire doesn't slip out of the tape. I've put a little screw here to put some tension onto the wire, and I just finger tighten it. I'll be applying the bulk of the tension to the wire by holding on to the end of it as the program runs. Once that's all set up and aligned, I set the Z DRO to 0 because that's where we're starting from. We're going to advance an inch. And now we're ready to run the G-code program. The G-code for making a spring is actually very simple. This first line here says set the spindle to run at 180 RPM, which on my particular lathe is the lowest speed. And the M3 actually turns the spindle on. The next line is the one we were talking about that synchronizes the spindle to the cross slide, which is a G33. This says move the Z-axis 1 inch while advancing the cross slide 16 thousandths of an inch for every rotation of the spindle. Now in this particular case, I'm using wire that's 14 thousandths of an inch. So I'm giving it just a little bit of extra room here so that the wire doesn't wrap up on top of itself. M5 turns off the spindle, and M30 ends the program.
And making a spring.
So, that's how I make a spring. And you can use this technique to make springs of all different sizes, both tension springs and compression springs. Like anything else, it isn't very difficult once you figure out how to do it. Now let's take a look at the sheathing that covers the control wires on the arm. I've highlighted some of it here for you to see. You can use a store-bought material like the sheathing on a brake cable on a bicycle, but I figured once we had this technique going, I could just make the sheathing myself. To do this, I'm using a much heavier 20-gauge stainless steel wire, and I'm also using a thinner mandrel. The procedure is basically the same. The only thing I had to change was the G-code to account for the thicker wire and for the longer length, which in this case is going to be 10 inches. As we start to make the sheathing, you can see that the mandrel is bending significantly, but it's really not affecting anything, and when the job is done, the mandrel will snap back to its original shape. And after the program runs, I now have my first length of sheathing. The torsion springs that fit inside the finger joints just aren't practical to make on the lathe, so I'm going to do those on the milling machine. They're made of a stiffer wire than we were using, and they're only wrapped 2 or 3 turns, forming this L shape. So what I did was I made a custom mandrel. It has a rod on it, which is the inner diameter I need of the spring. And then there's this little part here with a slot in it that gives me a place to hold the end of the spring to aid the winding. I'm going to place the mandrel in the chuck on my 4th axis, because the fourth axis allows me the ability to very precisely tell it just exactly how far to turn. The first thing I do is put a 90-degree bend in the end of the wire, which is going to help hold it onto the mandrel. And then I pull the wire once around the mandrel. You have to hold it really tight because this is a stiff wire. Then I give a command to the rotary table to have it turn 3.5 turns. And you can see that this would have been impossible to do on the lathe. The lathe is just moving way too fast. Then I cut it off. And we have a torsion spring. You just have to bend the leg out to give it that good L shape, and then we'll trim the ends and we'll fit it into the finger. In an earlier video, I said that I had to figure out a way to salvage the swivel joint from this larger part. Now the process itself is pretty straightforward. It's just a contour with the milling machine. And because a swivel joint tends to swivel, I needed a way to hold it firmly while I was making the cut. And what I came up with was this fixture, which is hollowed out to fit the bottom of the swivel joint and hold it firmly in place with the screw. If you like this video and would like to be notified when I release new videos in this series or in other projects, all you need to do is click subscribe. If you're interested in my other projects, you can find them at my website at www.zeman.com, or you can scan my channel here at KenTunes.
I'll be back.